All right. So you working? Ah, good. You have power. Let's see. So here, this problem here. Now, try to see why this would not work with washers or discs. Say again?
We always have a vertical line. We use more horizontal.
Yeah, exactly. Yeah. That would be a different level. So you'd have to talk about how do you apply a rotation transformation if you wanted to have a diagonal rotation axis. Does that make sense? We talked a little bit about that last time. I would just rotate the function, apply the normal method, and then rotate it back. But we don't know how to rotate things mathematically, really. Not surprisingly, it involves trig, but... So now, what's immediately wrong? If I want to use the washer or the disc method, if I graph this thing, it looks roughly, I think they have a picture of it. But yeah, and it's the first picture they have. It looks like this, basically. That's what that looks like. So it's between this function and the x-axis, and I want to rotate it around the y-axis. So if I use washers or discs, what is going to be integral d what? If I want to use washers or discs, it has to be integral d what? dy, because I'm rotating around the y-axis. Anything parallel to the y-axis has got to be dy. Which means I've got to rewrite this as a function of y. And can you do that? If you can, I will give you some extra credit. Right? Because you can't. You understand? You can't rewrite. If it was just that, I could divide by 2 and square root all day long. Yay! But that, no. Ain't going to happen. You guys got it with me? So that's a very simple example of a problem that you cannot do with washers and discs. But cylindrical shells will eat it up. And the reason, the one thing that really... There's more than that. But one thing that definitely sucks about this is whatever is true for washers and discs to set it up is the opposite for shells. Because of the way this works. If I want to rotate it around the y-axis, and I'll use washers and discs, I'd have to have an inner radius and an outer radius. Everything would be with respect to y. I'd be moving up and down the y-axis. My radius would keep changing. That's why it would have to be dy. If I want to use this with shells, here's a nice note to take. I draw my rectangles parallel to the axis I'm rotating around. You can kind of see that in the way I've done the stuff that I erased. But I have to rotate it like this. So I want to draw my rectangle parallel to the axis I'm going to rotate around. So then this is situated on the x-axis. Oops, got it. So it's going to have to be integral something dx, which is cool, because I have a function in respect to x that I cannot change. All right, so here's the nice part with this. Just remember that the main idea is that it's circumference, which is just going to be 2 pi times whatever the radius is, times the height, which is just going to be f of whatever the variable is. We'll say x here because of the fact that it's dx. And times the thickness, which of course is dx. So if I can figure out what my height is, I'm basically good to go. If I can figure out what my height is, that's the important part here. Because the circumference, I can go out to x. I don't care what the hell my shape looks like, where the hell it is. I'm going to find this at some x. That's going to be the radius. Right? Now, of course, if I'm not doing it on the axis, you have to do like +1 or -1 if I'm doing it at x equal to 1 or x equal to -1. It's going to be all that kind of stuff. Basically, we're just working off the axis right now. So my radius is going to be just x. My height is where things really matter. And this one's not too bad because it's hugging the x-axis. And I wanted to say this before, but do you see what I mean by that? It's hugging the x-axis. There's no distance between the function and the x-axis. It's right on top of it, right? So that means the height really is just going to be the f of x. If it wasn't, if it was a shape like we've seen before, like this one, then my rectangle would look like that. The height would be this function minus that function. You guys see that? So if you could just draw the function you're working with and one rectangle, that's all you need to figure out the parts. The most important part is the height. Secondarily, it's, is the radius something weird because I'm not doing it around an axis. Right, so in this case, I'm going from what to what? Where does this hit the x-axis? At 0. And if you factor this thing, 2. All right. So this is going to be from 0 to 2. This is all dx. My circumference is going to be 2 pi times the radius is just x because it's related to the y-axis. You with me? Radius is just, if it was around x equal to -1, my radius would have been x plus 1. Okay, maybe. That's my circumference. What's my height?
Function of x.
Good, just this. 2x squared minus x cubed. That's how tall it is at any given x value. That's the height of it. And then finally, I've got my thickness, which is just dx. I like it. So then here I can bring the 2 pi out. Here I get 2x cubed minus x to the 4th. And now should be the easy part. Now should be when you integrate this thing, it's not too bad. So what do you get when you integrate this?
1/2 x to the 4th.
Good. 11 x to the 4th over 2 minus x to the 5th over 5 from 0 to 2. And then you just plug that stuff in and get your numbers. All right. So it'll be 8 minus 32/5 times 2 pi. So whatever the hell that is. So 16 pi minus 64/5. I think it's 16/5 pi. Is that what I got? Yes. Yay. All right. So personally, I know this is still kind of new, but I like shells because it does look very much like what we're used to. We put the rectangles there. We're just taking the rectangles and rotating them around, making a big hollowed out cylinder. All right, so let's try a couple more. You guys try to draw as much of this problem as you can here. Let's see. This is the region. And I want around the y-axis. That'll work. And then we'll do one around the x-axis. So it's a region bounded by all these things here, right? So this is just the x-axis, y-axis, x equals 1, and this. So the first part of it is to figure out how to graph that in the first quadrant. And here, I'll give you that much. It's roughly... doesn't quite get there, but it gets down there pretty quickly. So it's the region bounded by this, the y-axis, and the x-axis. So this is the region that we're talking about. Okay, let me draw that a little bigger.
So that's all those 3 points you're saying is, here's your 3 sides of this whatever.
This
shape.
region, yeah, good.
And then the 4th side is the function.
Yes, I like it.
And
I like it. It's like trying to define the shape of a state.
Yeah, in actuality, you're giving us 4 sides of the region.
Beautiful.
2 y's and 2 x's.
I love it. Because this didn't connect with the x-axis, so I had to kind of stop it somewhere. Okay. So that's the region I'm rotating. I'm going to rotate that around the y-axis. So how am I going to draw my rectangle? Is it going to be standing up or laying down?
Stand up.
Standing up, because I got to draw it parallel to the axis I'm rotating. The minute I draw this is why this is so key. That is pegged right there, so it's got to be d what? X. X is going to find all my rectangles that I'm going to rotate, right? Okay. So I know it's going to be integral dx. I'm rotating around the y-axis, so the radius is just going to be x. I like it. So my circumference is 2 pi
X,
x. My height is
e to the negative x squared.
good because the height is there's no distance between the x-axis and that, so it's just going to be the whole thing, right? So I like to think of the cylindrical shells. This thing runs the body of it, whereas with the washer's discs, it kind of slices through the body of it. I don't know if that quite. That's the way I look at it. So here I'm going to put, in this case, the whole length of it works, so that's going to be the whole output. And one reason why I like this problem is it's how are you going to have to integrate this thing? U sub. And where am I going from to? 0 to 1. I like it. So we did a problem like this earlier with this kind of thing in there. So I just got the 2 pi sitting outside. What am I going to let u equal?
X squared.
Negative x squared? Because the derivative of e to the x squared is not in here. The derivative of e to the negative x squared is not also in here. The derivative of negative x squared is basically in there. Right? So I can't let u equal this whole thing. And du would just be negative 2x dx. So depending on the way you want to do this, I can bring my 2 back in. I want my 2 in there, and I want a negative 2 in there. Is that cool? So then my negative 2x dx is du. I had to put a negative to get the negative in there. My pi now is outside. This now becomes e to the u. And of course the integral e to the u is crazy. And u was negative x squared from 0 to 1. And now you just got to plug the 0 and the 1 in there, you're good to go. Right. Just be negative pi over e, right? If you plug a 1 in there, minus negative pi times 1 if you plug a 0 in there. So pi minus pi over e. Okay, so, oh shit. I shouldn't have done this one. I should have done the same one that we did earlier. We'll do that next time. Let me give you guys you guys stuck it out, so you deserve a practice test. I won't send it out to anybody else unless they email me. So I'm going to try on next Monday. Next Monday I'll have the answer key to this. So next Monday's review day. That last section in 6 is really easy, but I'm probably going to have to end up making it extra credit because I don't like to really test anybody on stuff that I just told you the day before the test. Does that make sense?
Is that on here? 6, was that 6?
Yeah, it would be number... Actually, I think there's only one problem on here from there, 5B. Because the last section in chapter 6 talks about how to find the average value of a function on a region. So it's just taking the integral, dividing by b minus a. That's how you find any average. Is you add them up, that's the integral, divided by how many there are, b minus a. There's my lecture on section 6.5, but I'm not going to officially count that as my lecture. So now you guys know the homework from section 6.5. 6.4 wasn't in our curriculum in the first place. Homework from section 6.5 is extra credit, since I ran out of time before I could get to it.
Is that on the other side? Already?
Remind me if it's not. I think I made it that far, but I don't know.
Just up to 6.3 then?
Say again?
Up to 6.3 then?
Up to 6.3, yeah. So that's the end of new material for the semester, if you believe it. Because we have a test, then we have practice for the final, and then we have a final. It's crazy. All right. Huh?
No class on Wednesday, just make sure.
Yeah, that's right. No class on Wednesday. I'll send out a reminder email. You guys have a good Thanksgiving?
That means I have to wait another year to learn more calculus. Like, freshman bracket, final.
Yep.
Okay. Is it like, I can learn thorough, like math? Well, actually,
It's
Or you're
gonna
not taking next semester.
cover topics from the whole semester.
okay.
You taking
It's not gonna be, you know,
No, I actually am.
it's not gonna just be the same thing as a final with number change, but it's gonna be all the concepts on there you have to understand to be able to do all of that.
Oh, okay. All right. Thank you.
Sure.
I don't know what my
Yeah. I'm teaching next door right now.
Oh, because somewhere you lost the negatives.
Oh, right there.
Yeah.
See?
You know, that kind of problem, that kind of mistake, it's not the one that's going to bother you. At least like a point or something.
Yeah.
If you understand how to set it up and how to start working it, that's the important part.
I understand how to set it up and work it while I'm talking back and forth.
Well, again,
This one seems to be a whole lot easier, like you said, than the discs and
the unfortunate thing, again, it only works for rotations, and it actually has a lot of problems too that, depending on if you have to break it up, or if it's rotating somewhere where it can't, you know, I could have easily done a problem like this, where it needs it in terms of y, and I couldn't do it.
Yeah,
Right?
so that's what I was going to ask you. If you change that around the x-axis right there,
Yes.
now that's fine to do.
That's fine with washers and discs. Yeah.
But you can't do it with
Cylindrical shells.
cylindrical shells because you can't put it in 7.
In terms of
Yeah.
y, 11, because it would have to be dy, exactly. So it is easier, but it's actually much more limited in what you can use it for. But the big thing there, I just wish I could have made this point even better. With washers and discs, it's all about finding out, you know, like if I want to rotate it around the x-axis, then it would be, x would determine, you know, the radius would be out to this function, right? And so then I'd rotate it and get there. But if I wanted to do shells, if I rotate this around the y-axis, then I'm drawing this like this, and that location is specified by x then.
Which is giving you your
Right,
height.
but I'm rotating it this way, so that's why this is going to be dx. But that's what kind of sucks about this. That's why if you're able to draw the picture, if I'm doing washers and discs, the whole thing is to be able to, it's pretty simple. If I'm rotating around the x-axis, then I know it's going to be dx. Then I know that x sets up my radius somehow, because it's got to be, where am I? I'm on the x-axis. I want everything dx, so I have to rewrite my radii in terms of x. Is that cool?
Yeah.
With shells, I'm going to set my rectangle parallel to the axis I'm rotating around, because that's the whole idea of it, is to get the shell after rotation, right? So it's set up by x in this case. Right? And then I want my radius is going to be in terms of x, but the height is what's really more important. That's going to be in terms of the function value. So I wanted to do that problem if I just would have left enough time, because this is a good example. We didn't do any examples where they're just floating there, right? Then this height would have been, the height would have been x minus x squared, right?
Yeah.
If I'm doing it around the y-axis. Sure. So the height would have just been that. I would have plugged that in for the height. So it would have been the 2 pi, and so the x doesn't care. As long as I'm on axis, I don't have any weirdness. It's just going to be x or just going to be y. You with me? And then the height, I just figured out is x minus x squared. So that's the most important thing to kind of do on its own before you start trying to set up the integral, is to write the expression for the height. So that you can get that there. The rest of it kind of sets itself up. Now, if I did it around this line, then the radius would have been x plus 1. Right? That was negative 1. Then that's the same as it was before. It's still going to be x minus negative 1. The radius would be x plus 1. It's the same kind of thing as before. That part we already kind of know and understand. This is the part that kind of defines this, is can you write what the height is? That's the most important part. And then I can, oh yeah, this would be 0 to 1, because everything meets it. 0 to 1, yeah. So x goes from 0 to 1 anyway. So there's just never quite enough time to do enough examples and enough, what's really important, what's the triggers, what do I really need to find to set this up?
Is there ever going to be like a function that one way would be better do disk and the other way would be better do shells, depending on the rotation you're taking?
Oh, hell yeah. Yeah, we were just saying, like, this would be impossible with washers the way it's set up, but if I made this x-axis, it would be impossible with shelves. You'd have to do disks or washers, yeah.
So it also depends on what your rotation is then.
Exactly, yeah. And we have the same concerns that came up last time with, does the function kind of change? We remember that we had that where they had that one that was like this, and then it was like that. But that's where it changed. If I was rotating it about a certain axis, I had to be careful about changing the integration from, this would be, I can't remember now. Oh yeah, so this would be one function of x and this would be another function of x, right? So that kind of thing still happens with this too. But I'm obviously not going to do anything overly extreme with this because we barely had enough time to talk about it. So if you look at it, can you remind me if I have 6.5 up? Since it is extra credit, you guys can still do it on the website. Yeah. And
I'm still on 5.5.
Yeah.
It's dying. I spent, like I told you this morning, or earlier today,
yeah.
I spent an hour and a half on a plane reading the book.
Oh yeah.
And I knew nothing more after I closed the book than I did before I opened the book. So
Write this down. I wish I remembered this. Remind me this next time. There's a place called Open Course Library, and I'm considering adopting the book. It's a free book. It's an online textbook. So you can print it out. You can actually have it printed out and sent to you. You hear that? Open Course Library.